Hi everyone, thank you so much for joining. Can you guys see me? Sorry for the delay. Looks like there is some issue with the screen, which we will just fix in a minute. But thank you so much for joining in. Um,
Tanya, go for it.
Okay, so welcome to the Move Forward Hackathon. This is the first webinar session of the Move Forward Hackathon, and thank you so much for joining in. My name is Tanya. I am the Web3 Marketing Manager at Alkimi, and today, along with me, I have Sandesh, who's a senior Web3 developer, and Darshan, who's a backend developer at Alkimi, joining along with me for this masterclass. We also have Anushri joining us from the Hacker Earth platform. Hacker Earth is helping us facilitate the entire hackathon. Before we move ahead and we get onto the agenda and we talk more about Sui and the Move programming language, I would just like to thank all the 6,000 participants that have registered with us, and would just like to reiterate that we also have a couple of weekly puzzles going on along with the hackathon. There is going to be a lot of small little activities which are incentivized where you can win exclusive prizes. And all of this has been designed to give you more understanding about the language, to make you more comfortable before the actual final hackathon. You can join our Discord channel, you can join the Hacker Earth website, you can check out the weekly puzzles over there. We're also dropping out a couple of hints on it. And moving on to today's agenda of what you're going to learn in this particular session, we're going to start with the introduction of the Web3. What exactly is Web3? Then we will move on to blockchains. Then we'll move on to Sui. We'll move on to Move. Then there's going to be a deep dive into the Move programming language, which will be followed by a problem statement. Like there was a weekly puzzle that we had sent out to you guys. So it will be solved during this live session by Sandesh and Darshan to sort of guide you on how you can navigate through the challenges that we're sending out to you on a weekly basis. And then you will have a small little session where you can send in your questions. Your I can see you're already sending in your questions in the comments. So all the doubts that you have, anything that you would want to get your answers for, we will be answering that in the 5 to 10 minute session at the end of a 5 to 10 minute section at the end of this particular session. So without wasting any more time, I would just hand over the stage to Sandesh and Darshan. All the best, and I hope you guys enjoy this knowledgeable session.
Yeah, thank you for the lovely introduction, Tanya. So let's get started with the masterclass. So my name is Sandesh, and I'll be presenting the masterclass with my colleague Darshan.
Yeah, thank you, Sandesh. Myself, Darshan Okar, working as a software engineer at Alkimi.
Yeah, so let's get started for what's the agenda for today, as Tanya has also mentioned. So we'll be giving a brief introduction of Sui and Move. We'll be doing a deep dive into the Move programming language and some common patterns and solutions. And at the last, we'll have an open Q&A session for anyone who has any doubts. So before we do actually jump into the Sui blockchain, so let's give a brief about what is blockchain, because understanding these basics will make everything else make sense as well. So what is blockchain actually? So think of blockchain as a digital ledger, like a notebook where you write down transactions, but with three special properties. One is decentralized, which means no single company or person controls it. It's run by thousands of computers around the world, and even if one goes down, you still have many which are still running, which keeps the service running. Whereas if you go to traditional Web2 services, if the server goes down, then everyone loses access. The second part is immutable. Once something is written into the chain, it cannot be changed or it cannot be deleted. It's permanent. Imagine writing in a book with a pen instead of a pencil. So that's what blockchain does. So you can't erase it. The third is transparent. Everyone can see all the transactions. It's like a public bulletin board. But don't worry, your identity is protected by cryptography. So what do you mean by this? People see the transactions and not your name or your personal data. So here's a simple example as well. Let's say you and your friends share a Google Sheet where you add your expenses. Right? So what actually happens here is, but instead of Google controlling the data or how the data actually flows, you control each and every point of it. And every time someone adds a transaction, everyone's copy is updated automatically, and nobody can secretly delete or change any of the data because everyone would notice. So that's basically blockchain. And there are a few key terms which you guys will hear a lot of the times as well, like blockchain, node, consensus, and smart contracts. So we will do a deep dive into all of these as well. But before that, let us also explain to you guys what Web3 is and how it came into the picture. So, Darshan, would you take it away?
Yeah. So you have some basic idea now, as Sandesh explained, what is blockchain and how it's working. So we will start with Web 1, how it evolved the Web 3. So how it came. The initial, in the early 90s, we are only able to view the data, like the information. It's more on read only. We can't, it's not an interactive way, but we can get the information, we can read the content. That's all. When it comes to the Web 2, we can able to interact with it's a dynamic page. uh, in early Web 1 is exactly like a static pages. The content won't change, it will be only read only data. And in a Web 2, there will be the interactive page, the personalized content, the social media came, uh, and you can able to post some data, the images, videos, YouTube, Instagram, Facebook, a lot of social media came. We can able to do a lot of things with that. So in the Web 2 side, the entire data will be controlled by one entity or one company. So actually the user won't have the exactly access, the controlling method.
Yeah, that is a very true, Darshan. As you mentioned, like the user will not have the complete access or the control over the data. So this is where Web3 comes into picture. This is where blockchain comes in, where you truly own your digital assets. The digital assets can be anything. It can be your data, your content, your money, your identity, and nobody can take it away from. There's no middleman or there's no company controlling it or controlling everything.
Yeah. In a Web 2, to add on that, the user can, the company can use it for, suppose you can state for, say it as for advertisement purpose, or they can use the personal data to anything.
Absolutely, these are very true points. And to avoid this itself, we came to Web3. So let's say in Web 2, let's give a simple example. You either rent a room. When you rent a room in someone's hotel or someplace, you stay there, you use it, but you do not own it. And they can kick you out anytime. So that's how Web 2 works. But when you come to Web 3, you own your house. You have the keys, you make the rules. Nobody can evict you, your house. It's yours forever. This blockchain is the technology that makes this ownership possible. So it's the foundation. It proves that you own something digitally. It may be anything. It can be your NFT, your crypto, your gaming items, your music, and nobody can take it away. So this is the revolution. This is why we are here today. And Sui is one of the best blockchains for building Web3 applications as well, and one of the fastest growing layer one chains today. And let me show you why as well. So, Darshan, if you could just give a quick introduction of who Sui is and what they do.
Yeah, sure. So Sui is a layer one blockchain. It's not built on top of any other blockchain. In market, we can able to see the layer one, layer two, layer three blockchains. But Sui is a layer one blockchain. It was created by the ex-Meta engineers. So it's designed specifically for one goal, to bring a blockchain to that next billion users. It's not just only for the crypto traders or one community. It's for everyone, the regular people using the apps that happens to be built on top of the blockchain.
Yes, absolutely. That is very true. So now it's not just for crypto traders, as Darshan mentioned, but for regular people using apps that happen to be built on blockchain as well. Right. So now let's get into what actually makes Sui special as well. Right. So there are majorly three things that make Sui very special. One is lightning fast. Second is cheap and predictable. Third is object-centric design. These are the three major things. And when we say lightning fast, what we mean is, let's compare to other chains as well. Like Bitcoin takes about 10 minutes per transaction, Ethereum takes about 12 to 15 seconds per transaction. But when we talk about Sui, it takes just 0.5 seconds for a transaction to complete. This is how fast Sui actually works. And what is the major reason for it being so fast? The main thing is because it has parallel transaction execution. Right. So we will cover this topic later on as well. The next point is it's cheap and predictable. What this actually means is the transaction cost comes around $0.001 per transaction. That is a tenth of a cent, not like $50 or $100, which actually comes in Ethereum during high demands. So the gas fees is very less compared to other chains, and there are no gas wars as well. You know how Ethereum gas can actually spike when everyone's trading, when the demand is very high. That doesn't happen on Sui. The price stays stable. Then we also come to the object-centric design. So this is huge, and it's the secret sauce behind Sui's speed, of how they are able to achieve that speed. Instead of having accounts like Ethereum, Sui uses objects. Every coin, every NFT, every smart contract state is an object with its own unique object ID. Think of it like in a video game inventory. Each item is separate. You can see what you own, move items around, or trade them as well. Not like a bank account where everything is lumped together in one balance. This might actually sound like a very small difference, but it's actually revolutionary because it enables that parallel processing which I mentioned earlier. So this is one of the major things what sets Sui apart. This is why Sui is perfect for consumer applications, games, social apps, NFT marketplace, anything that needs to be fast, cheap, and scalable. So Darshan, over to you if you can take it over for the object models.
Yeah, sure. So uh, if we come, so here we can able to see the comparison between Ethereum and Sui model. So as early Sandesh mentioned, Sui is using the object model. How it exactly differ from the Ethereum model? So under the Ethereum, everything will become under account model. So whatever the data, the balance, the NFTs, whatever the data you hold, it will become under the one account. So then you have to go with a sequential execution. But in a Sui, here everything will come under the object. So it will be different objects. In the Sui object model, we can able to perform a parallel execution. Let's say example like we are traveling through the road where we have one line. In that case, the each vehicle has to pass through the in a sequential manner. That's how we are execution will be done in the Ethereum side. But when it comes to the Sui, we have multiple lines, so the vehicle can move in a parallel way. So it will be very faster compared to the other chain. So that's why the Sui can able to handle the parallel execution in very it may take around a half a second to execute each transactions, right? Yeah. The next concept is object ownership. So in a Sui, there will be the three type of objects we are using: owned object, shared object, and immutable object. The owned object, which will come up with a single owner, it means that entire object will be owned by single account, single address. For example, we can say the NFT, the coin you are having in your wallet, the game items or staking position. So here the execution will be very faster because there is no concept of shared thing. So it will be very faster compared to other chain. In the shared object, the multiple users can able to access it and use it for the transactions. Here, as an example, when it comes to the shared object, uh, DEX liquidity pools, shared marketplace, multi-signature wallet, compared to the execution with the owned object, it will be slight delay because need to uh, get the consensus. We have to prioritize that which transaction needs to be execute first, execute next. So there will be the slight delay compared to the owned object, but compared to other chain, the process will be still faster. Come to the immutable object. This is like we are defining the constant. So when we need to read some value, we don't need to modify that value. Then we are going with the immutable objects. So as an example, we can see the package code, publisher metadata, and contracts. The it will be very faster because there is no need to get the consensus and all. So we are only going to read that value. There is no shared object involved here. Can you yeah. So here, the decision is like when you are going to use when to use which object. So if you want to, if you are designing something that only some one object needs to use, means you have to go with the owned object. When multiple people are doing the transactions, that time you have to go with a shared object. when when you are not going to change the value, but sometimes you need to initialize the value and keep it for future usage or to read that value. In that case, you have to go with the immutable object. So yeah, the next topic is move. So Sandesh, can you please take this and explain how exactly the move is?
Absolutely. Thanks, Darshan. That was a very good introduction on what are objects, what are the ownership types in Sui as well. So now let's do a bit of deep dive into Move as what Move is. Right? So Move is actually a language that is used in Sui to write contracts. And Move was designed with one goal in mind, that is safe asset management. Right? So what does it mean? It means Move makes it really hard to write bugs that lose people's money. So you may be thinking, how do they even achieve it? So they have something called as resource oriented programming. In Move, what we mean by that is every digital asset is known as a resource, and resources can't be copied or lost by accident. So what we mean by it's baked into the language itself. So the compiler, that's the thing that runs your code into blockchain code. The compiler will literally refuse to compile your code if you try to do something dangerous with an asset. It catches bugs before you even deploy it, not after you lose your money. So it's like a safety net for you. So let me highlight some of the key features as well of why it's very important. So linear types, what we mean by this is values move, they don't copy. If you have a coin and you pass it to a function, let's say you can't use that coin anymore because it's already moved. Let's say I have 100 rupees note, I give it to someone else, I cannot say I'll give that 100 rupees note to anyone else again because I've already given it. Right? That makes logical sense as well. You can't even duplicate it. You can't just copy it and print it again and say I'll share. I have 100 rupees. I'll just copy it and I have 200 rupees now. So that also doesn't work. This is prevented by the language itself. Then we come to the abilities system. We'll dive deep into this in a moment as well. It's basically like a permission control for your types. You control what can be copied, what can be dropped, and what can actually be stored. Then we also come into no re-entrance bugs. If you know Ethereum, you know about the DAO hack as well, the $60 million stolen because of re-entrancy. That literally can't happen in Move. The language prevents it by design itself. Then we also have uh, no integer overflows as well. At least it aborts instead of wrapping around silently and causing chaos. Here's a quick comparison as well of Move and Solidity. What are the key differences between them? So can Solidity prevent double spending by default? No. You have to code that yourself. It cannot do it by default, but can Move do it? Yes, it's built into the resource system itself. Can Solidity prevent re-entrance? As I mentioned, no. You need to use special patterns like re-entrance guard to prevent it. But Move does it as the language design itself prevents it. Can you accidentally copy valuable assets in Solidity, like let's say NFTs or coins? Yes, all the time. This is one of the major issues faced. In Move, you cannot do that, as the compiler itself will not allow you. The compiler itself will say, no, you cannot copy an asset. So what is the basic analogy from this as well? If Solidity is like JavaScript, right? So it's flexible, powerful, but there is a high chance you can miss some things and make mistakes as well. Whereas Move is like Rust. It is strict, it is safe. At once your code compiles, you know it's solid. Then you don't need to worry about there are bugs or there's some issues as well. Now, some people hear strict and think, oh, it's hard to use, but that is actually not true. Once you understand the core concepts of it, Move is actually quite elegant and easy to learn as well, and the trade-off is absolutely worth it. So let's move on to the Move fundamentals. Here we will uh, dive deep into how Move code actually works and what are the basic anatomy of it, and how do we actually write code in Move as well. So first, you need to understand how Move code is organized. Everything in Move is organized into modules. Think of module as a smart contract module, as smart contract in Solidity, or a class in other languages. At the top, you declare your module with this syntax, as you can see on the slide. The second, you import your dependencies, what all dependencies which you will actually need in your contract. The third one, the third is the structs. So what are structs actually? These are how you would define your objects. What data will they actually have inside of them? Note that there are multiple note that there are functions as well, which we have in public struct. We have an object that has the ability named key. So what does this actually mean, right? So key is part of an ability, which actually means it has a global storage. It is identified with an object ID. The ID is unique. That ID needs to be present. Then you also have functions. There are basically three types of functions. One is a public entry function. Then we have a public function and a function keyword. So what is the difference between these three? So we'll get into that as well. So when we talk about a public entry function, these are callable from transactions. From outside, these are your entry points. Users call these from their wallets. When we talk about public functions, we say that these can be called by other modules and they can return values. When we talk about only function keyword, these are private to this module only. These are similar to internal helper functions. These cannot be used outside or be called from outside of the contract as well. So the main key concepts are package name and module name. So what is the difference between these as well? So package name is your unique identifier. It's like the name of your package, whereas the module name is like the import name, the specific module which you want to use. Then, as I mentioned, we have the use statements and public entry function, public function, and function as well. And we also have the mutable transaction context, which actually gives the metadata of the user who's actually calling it. So this data we will be getting from the context. Then we come to the abilities system. Now let's talk about ability system. This is one of the most important concepts in Move. Abilities are basically like permissions for your types. They control what you do with a type. There are basically 4 abilities as mentioned. One is copy, drop, store, and key. So what does copy actually means? It means you can duplicate the value like copy and paste. Drop means you can ignore or discard the value. It just disappears. When we talk about store, it means you store this inside other structs. Important for collections similar to coins or NFTs, you need to store them. Then we have the key, means this can be a global object with a unique ID. Can be owned, it can be owned, it can be transferred to other people as well. Some of the basic examples as we can see here as well, right? So looking at the metadata, we can see that it has a copy and drop. That means you can copy metadata freely and can ignore it if you want. That's fine because metadata isn't much valuable. But when we were to look at the coin, right? So when we were to look at the coin struct, it has no copy and no drop, but it has a key and a store. So what is the difference? You cannot copy a coin. The compiler won't let you because you can't duplicate money. Like that just doesn't make sense, right? So you cannot just drop a coin and you forget about it. That the compiler won't let you. You can't just lose money. So that is why we can't use copy, nor can we use the drop keyword here. We cannot use those abilities in these examples. Then we have one critical rule in Move: no copy and no drop for resources. This is because each important object is considered as a resource, and resource, as I mentioned, can be anything. It can be your data, it can be a token, it can be your NFT, something that holds value. That should not be able to, anyone should not be able to copy it, nor should you be able to drop it. Like $100 bill, let's say, like 100 rupees bill, like you can't just photocopy it and say now I have 200. Like that just doesn't make sense. And you can't just throw it away. Like you can throw it away, but that just doesn't make sense to just throw a 100 rupee bill away. And you must be able to track it explicitly. That is where the store keyword comes into play. That is why we store that particular struct. Yeah. And then we come to resource safety examples as well. Something wrong with resources. This is where Move really shines. So let's see the mistake 1. If you can see, the mistake 1 is losing assets. It won't compile. So when we see here, we have a function, public function, but we don't have a return function for it. We are not doing anything. We are just dropping the value. But we are using money, right? We are using a coin there. What actually happens behind the scene is Move will see that you're trying to use an asset or resource and you're not doing anything with it and you're just dropping it. Move will not let you do that because it's like you're just throwing away money. That makes no sense. So you will get a compiler error. Unused value must be used. You must make use of it. The second is duplicating assets. It won't compile as well. So as you can see in the function here, which is mentioned, the compiler will throw an error that use of moved code. It means you have already assigned the value of coin to, and you cannot assign it again. Like that, you can't give away money which you have already given away. So these are some of the examples. Then we also have use after move. It won't compile. It won't compile because you have already transferred that value. It's already moved. You cannot use that value again because there is no value to use at that point. Next, we have the explicit handle. That is, when we talk about explicit handles, we mean, as you can see in the function, there is a burn coin function. Now, what this does is, when we burn any object or any resource, we need to destructure it properly, and then we need to explicitly delete the ID. This is a satisfactory condition to actually run it. So in this scenario, this will actually compile the code and the function will actually run. Similarly, we also have transfer ownership, where we transfer the ownership to other people as well. And we also have merge fine as well, where we can merge multiple object IDs as well. Yeah, the lesson. So what do we actually get from this? That Move compiler is actually your safety net that catches the bugs at the runtime itself. And because for other contracts, for Solidity and everything, bugs appear at runtime and have cost billions of dollars as well. This is why Move is the future of smart contract programming for all applications. So this is one of the major features as well. Now let's get into our first contract, that is a counter application. So let me give you a brief about what we'll actually be doing in this as well. So what we will be doing is we'll create a simple contract which we will deploy it on the testnet. This contract will have a simple function, that is anyone who calls it will be able to add a counter value, right? So let's see how we can start with this from what all we have actually learned.
So it's the one of the challenge we gave in the hackathon, right?
Yes, absolutely. So as Darshan mentioned, so we also have a hackathon. If you want to learn about real world problems as well, then the link will be mentioned in the description, where you will get to solve and implement all of these things which we have actually learned here as well. So let's see. So first of all, we need to create the counter. So the first function is to create it. So as we can see here in the code as well, what is the proper way to create it? What do we actually need in those as well is actually given. So just for reference, this slide will also be mentioned in the link in the description. So you guys can go through it as well at your own pace. So as we can see, then we need a modify function that the owner can increment. Then we also need a view function, because we need to see what is the current value of the counter as well. Then we also have the batch increment. Let's say we need to increment at steps of 2 or 5. So for that also we need to add a function. Then understanding the code, what is the core concepts of this? So when we use ID, every object actually needs a unique ID, which is generated with object. And then we also have the required key ability as well. So what this does is it adds the unique ID to it, that it needs to have an ID field. Then when we see, we also have the entry create function, which has the mutable context as well. So entry means it's callable from transactions. Context means it gives the metadata of who's calling the transaction, and creates a counter and gives it to the caller. Then public function, entry function, the increment counter. This takes the mutable reference, and you can modify the counter value, and the caller must own this counter to pass it. He must be the owner of it. So this is one of the major features. And then we have the function value, where we actually take the reference of the immutable object and just read it. We don't modify it or edit it. Then we also have the context of the sender. This is to get who's actually calling the function. Let's go to the second contract as well. This is the NFT contract. So as I mentioned, this will be the link will be in the description below, so you guys can go through it and try to analyze this function as well. And if you guys have any doubts, you can let us know in the comments. Yes. So let's now go to shared object walls. So Darshan, would you take it away, please?
Yes, Sandesh. you have already explained about the owned object with a great example of counter. So here it comes, as early we have mentioned about different objects model, the owned object, shared object, and immutable objects. So this is the one of the example for the shared object. Um, so here we will be creating the shared object, and the multiple people able to access it and able to do the transactions, right? So here in this line we are just importing the required packages, and yeah, can you go to the next? Yeah. So here we are in the shared wallet structure. We are creating this struct as a class early mentioned. So it's a data type, the custom data type we have defined for the vault. So in the next function we are creating the vault with a when we deploy the contract, we will be calling the initialize function. This create function will be called. So the vault will be the vault object ID will be generated. By default, the owner will have the access for all of the object IDs. Here it comes the you can able to see the line, the transfer shared object. So here we are making that anyone user can able to access this object. Earlier it was like the one user have like those who are the owner of that object, he can able to access it, or he can able to do the transaction on that. But in this shared object case, anyone able to access it and able to do the transaction over that. So this is the same code we have. You can go through it again. The entire code will be available in the this document will be available in the description. You can get into that. So we just use the inbuilt functionalities. The everything will be handled by the Sui itself. The transfer, public, the coin take and all. So you can go and look into that how exactly it's working. So this is the function. Yeah. So the public entry withdraw function that we have given here, this is for example. Don't use it for the production level because anyone can able to do the withdrawal for this. So it's like for reference, not like a production level code. Okay. Yeah. So can you go to the next slide? Yeah, this is the function. We'll get the balance and get the total deposit. So these are the function to get the information, the how much token is deposited to the vault, and uh, next one is get balance, the current balance, the available balance from the vault itself. So as the access control capabilities is the one of the crucial part in this Sui module, because when we come up with a contract, some part of the contract we need to restrict to some few users itself. Suppose we will say that admin can only do that certain kind of operations, not all the users able to do those operations. So while this access control in other contracts, how they have implemented is they will just verify that address is matching with uh, the provided address. But the who is calling that function, the executing the function, that address, they will verify cross check with the address is present in the contract, or the value present in the contract. But suppose someone can able to manipulate the value, and sometimes he can able to execute those transactions also. But when it comes to the Sui, it will create the object that will be owned by one user. Suppose we are going to create a, okay, in the next slide we have the admin capability function. Here we have defined the struct as admin cap as key and store. So the key will be generated, that object ID will be belongs to the one particular wallet. So if you don't have that admin capability object, you are not able to execute those functions. You can't even try it out, because it won't even possible. uh, it will be bounded to your wallet address. So even it can't be transferred without that wallet owner signature, means that wallet owner approval. Without knowing him, we can't do the admin capability transfer and all. So if you are going to transfer the admin capability, then it will generate the object ID. That object ID will be holding the entire admin capability. So those who have the access for that admin capability, he can able to perform those actions, right? So here we have the admin withdraw function. Here we have mentioned the admin capability. So this admin capability reference will verify that whether the user have that object and all. If that user doesn't have the access for that object or own that object, it won't allow to execute it itself. So yeah, there we have one more function, right side, the public entry function, transfer admin. So how this is the way to transfer the admin capability from one admin to one more the another person. It's like we can create multiple access control things. Suppose if you want to create for minting, only the mint admin can be created, or any certain case, or any certain suppose if you want to create NFTs, so he will have only capability to create NFTs. So it's like the limitation, to do a certain kind of operations. Yeah, we will go to the next step, the the test conditions. So uh, the testing is very crucial when it comes to the software, because without doing the unit testing, we can't go with the production level, because it will be the very difficult. We might miss some cases while developing the feature, but while doing the while we writing the test cases, we will found that those issues and we can able to fix those. And this is the test case. The, the, the test is mentioned here. Okay, so the test we have mentioned here, right? The function test multiplier counters. So this test will specify that this is the test function. It won't be available in the production code. The once we deployed the code in the contract, right? That contract won't contain those codes. It will be only for testing. When we have developed and compiled the code, we need to do the one round of testing. In that time, we will the Sui by default will give the commands to execute it. So once we will use Sui move test, it will execute all those test conditions, and it will verify whether the test cases are running or not. We only need to write a code that needs to be verified. Like uh, in this case, we have written the test cases for counters. So we are testing whether the counters incremental is happening or not, right? Yeah. So these are the the commands given. These are the inbuilt commands. So Sui move test, as I earlier mentioned, the Sui move test is to it will do the it will execute all those test commands, and it will give the result. If there is any issue, it will throw the error. We can able to go and we can able to solve it. And if you want to run some specific test cases, we can able to mention that test case function name and able to run those. And yeah, uh, yeah, these are the test structure. How what are the test structures are covered. So you can able to go through it, and these are the basic functions. Again, we have written here. So okay. Now, Sanish, can you explain this, the common mistakes while we developing the smart contract? What are the common mistakes we will do, or how we can avoid that?
Yeah, absolutely. Thank you. That was great on the testing part as well, because most of the people will write a contract or write code but will not test it. So testing is very much important. Never skip testing, guys. So let's go on to some of the very common pitfalls. So Darshan explained to you how you can actually write test cases. So let me show how you can actually save hours of debugging by not making the same mistakes which most of the developers actually make while learning. So the first and very major is not handling resources correctly. As you can see here, the compiler will tell you that unused value that must be used. Always transfer, destroy, or return resources. Do not just let them disappear. Then we also have explicit handles as well. So as you can see here, this is the correct way to actually do it, where we return the object or ID or delete it. Then we also have integer overflow. What this actually means is move aborts on overflow, but you should check first with assertions as well. So what we mean by assertion is that always check if that value is correct, else we stop the execution or transaction there itself. Then we also have missing abilities. If you want to store an object in a dynamic field, it needs the store ability. If you're missing it, then the compiler will throw an error that you need to add it. Then we also have add required abilities. Then we also have overusing of shared objects. This is a performance mistake most of people make. The thing is, if only one person needs to access something, make it owned. Shared objects are slower because they need consensus, and use them only when necessary. Do not use them everywhere. Then forgetting to add check inputs. This is one major thing. Always check your inputs before doing operations. Users might pass crazy values, so always validate everything. These are some of the 5 mistakes which, if you avoid them, you'll save yourself so much of debugging time. Trust me, we've all made them. So these are very common. Now let me show you some of the quick pattern references as well. So what are the quick patterns that are actually used in Move? So the first one is create and transfer. So the basic object creation pattern for every object that you make. Then we also have the modify owned object, that is takes a mutable reference and uses this to update the object. Then we also have a transfer owned object. This takes ownership and transfers it, so moving objects between 2 different wallets. Then we also have a working with coins. So when we are working with coins, we need splitting, then checking of value, then giving change, which are very essential and the core for DeFi as well. Then we also have emitting events. This is super important for indexers and front ends to actually track what's happening on chain. You always use event and emit. When you emit an event, it can be stored into the backend as well for Web2 purposes, where you can retrace it back. For the front end as well, to actually know what event is called and if the transaction is successful. Then we also have dynamic fields, like this is like a hash map or dictionary. You can add arbitrary key value pairs to any object, which is a very flexible storage as well. Then we have a one-time initialization, the init function. This is the core of it. This function runs once when you publish your contract. This is perfect for initializing and setting up admin caps, shared objects, and most of your structs which you actually require. So all of these patterns, you'll see them again and again in real code bases. The Sui example repository is full of them, and we also have it in the hackathon as well. So you'll see these patterns repeating and being used in real world problems. So let me show you to actually how you actually run these commands as well. So this is the deployment workflow commands. These are some of the very basic commands which you will actually require and you will constantly use them. So we'll not be going through all of them. So you can screenshot this and find it in the slides, but we'll also have it in the description below so you can download it and go through them later as well. So these are some of the very important ones which you'll be using regularly. We have the client setup, we have the get testnet tokens as well. We have how to deploy, how to actually call some of the functions to execute transactions. Then we have inspection elements, like how do you inspect what what object actually contains, what the transaction block actually has, and all of these things as well. So these are some of the very useful tools which you guys will require to get you equipped and started with Move and Sui as well. Then we also have the resources, which we will mention all of these links in the description below, so you guys can go through them and learn as much as possible. So this is almost it for today, and let's open up for Q&A. So Tanya, if you can just take it over.
Guys, this was an excellent session. I think there were quite a lot of insightful, knowledgeable slides on there on the presentation. And moving on to the questions, we have the first question here. Niranjan is asking, are there any design patterns we should follow, or for our contract to stay more efficient and secure and flexible in these parallel execution scenarios that you were explaining just now? Any one of you can take that up. Can you guys hear me?
Yeah.
Yeah,
For the first
go ahead.
question, as I can see, are there design patterns we should follow? Yes, absolutely. There are specific design patterns which you should follow. As you mentioned in the seminar as well, that you should follow the object models and that specific pattern, the ownership, transferships, and whenever you actually write a contract, make sure you write it with owned objects and reduce shared objects as much as possible.
Thank you. And the next question is from Gautam. Gautam is asking, also, he's given you a compliment.
Yeah,
He's
sure.
saying, beautiful explanation by
Uh,
Darshan. He's asking, can you please explain a bit about the parallel execution in Sui?
yeah,
And
sure.
then there's going to
Uh,
be a follow-up
this
question on
parallel
that.
execution in Sui. So, uh, when it comes to the object, right, the each object will be independent. So it will take out altogether, and it will process parallelly. So unlike the Ethereum, it will take entirely into the queue, the mempool, and execute the transactions one by one sequentially. But when it comes to this Sui transaction, everything is a object. So each object, if it is not a shared object, it can execute in a parallel level. But when it comes to the shared object, the consensus needs to be taken care of. Like we need to decide, the system needs to decide which one needs to go first and which one needs to go next, because if it is going at the same time, right? So if it is not a shared object, if it's a owned object, so we can go with a parallel execution. The system will take care of that.
Thank you, Darshan. And a follow-up question on that is with while so Niranjan is saying with the explanation that you have given, while multiple transactions are happening in parallel and reference shared objects, how does Sui runtime manage dependency resolution and still maintain proper execution? Would you like to shed some light on that? Any one of you?
Yes, absolutely. So, what this actually means is, as Darshan mentioned, for shared objects, right? We cannot have parallel execution for those. We have parallel execution only for owned objects. This is mainly possible because owned objects are processed in parallel, because they are not shared between two different wallets or anything. But when we come to shared objects, they cannot be processed parallelly, because we need a consensus from all other parties who are actually owning that object as well. So this is where the shared object and own objects split and come into difference. As for the question as well, the runtime dependencies. So what Sui actually does is, if the dependencies which you mentioned, right? Let's say if it's a token or any other thing which you depends on another contract. So that time what happens is, it the object or the contract is an independent body. So it's an owned object. It's not a shared object. So because of this, parallel execution is possible.
Yeah, to add on that, once the transaction is done, the Sui will maintain the versions for each object. So they will verify that version, and because sometimes we will end up with a race condition. To mitigate that, the Sui came up with a versioning model. So each object will contain some version. When some transaction happens, the version will keep on increasing. If it in case of the shared object, it will consider that versioning based on version, the process will happen in the sequential manner.
Thank you, guys. And we have next question where Sanjana is asking, are there like any debugging or testing tools specifically to the Move language or Sui network? I'm sure this question has been covered in the testing part on the slides as well, but we will uh, probably just take this up again. And then on a follow-up question to this is, can we integrate off-chain data like APIs into Move-based smart contract?
Yes, absolutely. So for the first question, are there any specific testing tools? So as we mentioned in the slides as well, there are a lot of tools which are actually present and a lot of commands which we have already covered in the slides as well. So they can go through those for testing. So there are a lot of materials which are available online to how to write test, how to test them, how to integrate them. And as for the follow-up, how to integrate off-chain data like APIs. So this is where the emit function comes into play. So what it actually does is, in the backend, we can have a listener where the events which are emitted from the contract can be listened, and we can store those on Web2. Like we can store it in DP, or we can even listen to it from the front end as well.
And we can use it for analytics if you want. And to add on that, the Sui will be coming with the SDKs, the JavaScript SDK and Rust SDK. So you can use that SDK to interact with the contract itself. If you want to call some function, so then you just need to use the SDK, and you can interact with the contract. You can expose the API. So from the API side, you can able to interact with the contract side also.
Okay, that's a great explanation again. And there's another question for you, Darshan. Can you explain a bit about backend interactions with Sui blockchain?
So it depends on the case, like what exactly we are going to integrate. So sometimes if you want to do some kind of deposit and all, we can expose the API, the internal API with a API key or protected something like that. And it can, we have to set up a secret, because the blockchain needs the signature every time. For that, we have to keep the signature, the wallet private key in some secure manner. The infrastructure level, we have to make sure that it should be very safe. So if it is compromised, anyone can able to do the transaction with that. So we have to be very we have to make sure that with the security things, because we can't just use the backend or some system to interact directly with the contract, because it involves the private key. So chances of security breach will be there. So compromise.
Got it. Next question is from Dilip Kumar. He's asking if there is a shared object in the priority queue. What is the criteria that is needed to mitigate race around condition?
Yes, absolutely. This is a very good question as well. So when we mentioned about shared objects, right, they are not processed parallelly, they're processed sequentially. Okay, when these are actually processed, we need to handle it in such a way that we have a set of priorities of which functions actually need to be called first. For example, when we talk about financial transactions, we need to make sure that those transactions are not put behind the queue. So those transactions need to be prioritized. there, that depends from business to business or developer to developer. What are the transactions they actually need to prioritize first? They need to handle it in the code itself and then execute the code.
Thank you. Mayuresh has a question. I get that Sui's move language enforces ownership, but do you think this stricter model could make developer less flexible compared to could make development, I'm sorry, less flexible compared to Solidity, or does it eliminate bad patterns entirely?
Yes, this is also a very good question. So the main thing is whatever you can do in Solidity, you can even do it in Move. So the flexibility part is not compromised there. It is as flexible as Solidity. And the main thing is, as Mayuresh has already mentioned, it just eliminates the bad patterns entirely, so that you never add a copy to a coin or any other resource or just drop any value. So this makes you a better developer, as it restricts most of the errors during the compile time itself.
And it increases the security also, because the object will be under the ownership of that particular wallet. So
Got it. Thank you, guys. Another question we have is from Deepa. She's asking, can you explain the concept of ownership in the Sui move language and briefly describe one bad pattern, like a reentrancy attack that is that can restrict ownership model, which is designed to prevent.
Yes, absolutely. So what do we mean by ownership actually? So ownership means that a particular wallet owns that object ID. It's not directly under your account, like similar to how Ethereum has it, right? It's an individual object which is linked to your account. Okay? So because of this, what actually happens is you own that object, but that is still an independent object itself. So you can transfer that to anyone else. So that is what you mean when you say ownership transfer as well. And what we mean by re-entrance attacks and everything as well. So let's say, as Adarshan gave a good example during the code as well, like when you have a vault and anyone can withdraw it, you don't have ownership cap or anything, so that only the owner can withdraw it. So then that's an issue, because anyone can withdraw funds from your vault. Like that's a very big issue. So because of this, we have the ownership concept where only the owner will have the capability to withdraw funds.
Thank you, Sandesh. Another question is sort of a follow-up question. Can
Mhm.
you explain what happens if commit transaction fails?
Yes, absolutely. So when a commit transaction fails, if you are talking about in blockchain, right? If any transaction fails, you can see it on the Explorer. For example, if it's an Ethereum transaction, you can see it on each scan. If it is a Sui transaction, you can see it on Sui scan or Sui Explorer. You can actually see why that transaction has failed itself. And there is one more thing. If you pass any object ID or anything which is not owned by you, right? So the dry run itself will fail. You will not be able to even execute the transaction. So there is no gas fees which is actually involved in this. And if it actually even fails, you can just check on the Explorer and see what the main issue was. It can even be as simple as you don't have enough gas fees, or you're not eligible to make the transaction as well.
Thank you so much, Sandesh and Darshan. I think those were all the questions that we have gotten. Uh, I think this has been an excellent session. I will just put up the Discord link for anyone who would wish to join We keep sharing really good resources over there. If you want to have links, links to, or sorry, hints to the weekly puzzles that we're dropping in. We also have a very small, very easy, simple, incentivized competition going on, where you can just, uh, make 5 commits on GitHub, you get to win 250 rupees. And then that is alongside the prizes that you can win from the weekly puzzles. So make sure to check out all of these little competitions and weekly puzzles going on. It is also listed on the Hacker Earth website. And we have announced a lot of winners, but we have one winner remaining for the week 2 puzzle. And that winner is Shivangi Bhargava. Congratulations, Shivangi, if you are on the live session. We have absolutely loved the code, and thank you so much for participating. I would just like to thank everyone for all your questions, the comments. Uh, at the end, I would just like to say that this was the first session of the Move Forward Hackathon. This was the first webinar session. We wanted to cover the basics. We wanted to touch down on the from the grassroots level, but we will be back with another session where we can get into more complexities of the programming language, and we can do a deep dive into the Sui ecosystem. So thank you so much for joining in, and I hope I see you in the next session. Thanks, and bye bye.